Welcome back to JCE eConnect e-learning portal. In the previous videos, we discussed about the R2R ladder type of the diac, and also we discussed about how the operation of the successive approximation of digital to analog converters and many more. Okay. In this video, we'll discuss about the another type of the A to D converter, that is dual slope type of the analog to digital converter, and this is the last bit of your fourth module. In this module, we'll discuss about how the conversion takes place in case of the A to D converter. Okay, so let me start with what exactly the dual slope analog to digital converter is. So it is also known as this A to D converter, or dual slope A to D converter is also called as a counter type of ramp A to D converter or digital type of ramp A to D converter, and there are many linear ramp analog to digital converters. There are many names that we can call this type of the converter. Okay, now this applications, if you're talking about the applications of this A to D converters, so this A to D converters is most commonly used in almost all the measurement instruments or measuring instruments. So say for examples, we have a digital voltmeters, digital multimeters we have. So in those digital voltmeters and digital multimeters, we'll find this type of the converter, analog to digital converters. Why? Because there is a conversion. Digital voltmeters, there is a various conversion methods is required, so various conversion technologies are employed, so that is why. So because of those reasons, in almost all the multimeters or in the digital voltmeters, so this type of A to D converters are one or the other way type of A to D converters are used in the almost all the digital voltmeters, but in most of the measuring purpose, so this A to D converter is used. Okay, that is the application of this analog to digital or dual slope A to D converter. Okay, next is this is dual slope block diagram. So it is a block diagram representation of dual slope type of analog to digital converters, so which consisting of a switch, comparators, oscillators, AND gate, control logic, counters, and the register to store the bit. Okay, this is the block diagram of the dual slope analog to digital converter. So you just see the first block, that is a switch. So the switch is used to switch the input from switch the position from reference voltage to input voltage. We have two signals. This one is a reference signal and another one is a input signal. So to switch between the reference and the input signals, so there is a switch is used. So that switch is controlled by the control logic here. Control logic you can see at the right hand side here. So right hand side, so the control logic will controls the operation of that particular switch, that is from switching to analog to reference to analog voltage. Okay, so let us take the switch is at the position of the analog input side. So when the input is given to the comparator, first comparator, it is a integrator. You can just see the circuit, first comparator circuit, first op amp, it is a integrator. Okay, so the signal, input signal is passed to the integrator. So the capacitor starts charging here. So capacitor starts charging, there is a linear type of ramp is produced. So when the capacitor starts charges in the linear way, so there is a output voltage will be rises linearly and the capacitor starts charges in the linear fashion. So that will be appears at the second op amp here. Second op amp, so another terminal, that is positive terminal of the second op amp is grounded. So first op amp is an integrator. So based on the input which is received, so capacitor starts charges, linear positive going ramp is produced. Okay, and that positive going ramp will be appears at the second comparator. The second comparator negative terminal. So the second comparator positive terminal is grounded here. So the output of this is given to the AND gate. So output is, so if the output of the first comparator, okay, if the output of the first comparator, if it is greater than 0, then only the second comparator will continue. Okay, so if the output if the first comparator is less than 0, your second comparator, because the second comparator is another terminal is also grounded, so both are 0, the output will be 0. Okay, so this comparator will works properly when the input is greater than 0. So when the input is greater than 0, the second comparator will compares that with the reference 0 line, so then it will produces the output will be 1 or 0. So the second comparator output is, say for example, so the first comparator output is also greater than 1, so the second comparator receives the same signal and the output of the second comparator is also greater than 1. Okay, then it is output of that is given to the AND gate. Okay, so then AND gate is another terminal is provided with the oscillator or clock pulse generator. So then it is fed to the AND gate, both the terminals get, one terminal will getting the output from the second comparator, other terminal will receive the output from the oscillatory circuit. So if AND gate function is, it is a multiplication. So if the output of second comparator is 0, so 0 is multiplied with the clock pulses, the output of the AND gate will be 0. That is why I said the output of the comparator should be 1 to receive, to get the required output. If it is less than 0, the output will also be 0. So that is say for example second comparator output is 1. Okay, then the oscillator continuously generating the clock pulses, the clock pulses into multiplied with another terminal, that is 1, the AND gate output will be the clock pulse here. So clock AND gate function is to multiply the two input signal. So the clock AND gate output will be clock pulse. There is a continuous clock will be generating. So the next, so continuous clock will be generating in the positive manner. That is why positive going ramp is produced. So when the positive, sufficient number of positive going ramps is produced, the control logic will send the signals to the switch to switch from analog input to the reference voltage. So then which will initiate the discharging of the capacitor. If the reference switch is moved to the reference terminal, then the capacitor starts discharging, then the negative going ramp is produced. Okay, the negative going ramp is produced, and the output of the integrator is also 0, then your comparator is also 0, then it will be 0. So these clock pulses, this is the second case when the input is switched to the reference voltage. So in the second what happens, so these whatever the clock pulses generated from the first procedure, when the input is at the analog terminal, there is a clock pulses are generated. So those clock pulses are counted by the counter. Okay, the counter is continuous to count the clock pulses generated. Okay, and then they are stored in the registers. Okay, so in the second half cycle this counter will resets, and once again the counter is ready to count the second set of the pulses. Okay, so those counter stored values of the counters are stored in the registers. So that registers, that is connected to the digital output display devices which will display the digital signals. So in this way, so analog form of the signal is converted into digital using this dual slope type of the A to D converter. Why it is called as dual slope means, so because of charging of the capacitor in the positive direction, so it produces the positive slope. So when the capacitor is discharging, it is producing a negative slope. That is why it is called as a dual slope type of the analog to digital converter. So this is the functionality or operation of the digital to A to D converter. Okay, next this function is already explained here, capacitor discharges, everything is already explained in the block diagram, you can just refer. So next type of A to D is flash type of the A to D converter. So it consisting of, once again, another type of the A to D converter is flash type of ADC or parallel ADC. This is called as a parallel ADC or flash type of the ADC. So once again it consists of a series number of the comparator. The comparators are connected in a series fashion, each one comparing the input signal to the unique reference value. Each comparator will compare the input signals with the reference value, and then it is produces the output. So the comparator output is connected connect to the inputs of the priority encoder. Then priority encoder circuit, there is a circuit called the encoder. It is connected to the encoder which produces the binary form of the output. Okay, next this is the block diagram representation of a flash type of A to D converter or parallel A to D converter. So flash, why it is called as a flash A to D converter means, so it is a processing speed of this type of A to D converter is very much fast. That is why it is called as a flash A to D converter. Okay, so processing speed is high, that is why it is, compared to all the type of A to D converter, the processing speed of this is very much high. Because of that only it is used in most of the electronic applications. So it is for the block diagram of this flash A to D converter. So this once again, so analog input voltage exceeds the reference each of the okay, that I will explain here. So when the reference voltage is given, so you can just see the reference voltage is connected to the different resistance terminal, and all the comparators are connected in a series way. So all the comparators are connected in a series way, and the analog signal is given to that comparator. Another terminal is given to the reference voltage. Okay, so another signal is given to the reference voltage, and the one terminal is connected to the analog signal. So this analog signal is compared with the reference voltage in the each stage. Here series number of parallels are comparators are connected, so there is, it will be the resistance leg will be acting as a voltage divider. So each time, at the each resistance, the voltage drop will happens. Okay, so it is connected to different comparators. So this, for comparator 1 2 3 4 5 6 7 comparators are there. In each step, the comparator compares the reference voltage with the analog signal and produces the output voltage. So all the 7 output voltage outputs of the comparators are fed to the priority encoder. So this priority encoder will stores the, it will stores the binary digits based on the highest number of the priorities. So which comparator produces the highest value of this highest value of the output, so it will encodes it and then it will stores in the registers. Okay, that is the operation of the here. So there are once again pin number 1 2 3 4, they are the parallel output, binary output. It is it's a 3-bit flash ADC. If it's a 4-bit flash ADC, you will get the 4 outputs, that is D0 to D3. As it's a 3-bit ADC, you will get the, say, D0 to D2. They are the parallel binary output voltages. So this priority encoder will catch the output of all the comparator and encodes it to the binary values. So this way the analog input of your flash ADC is converted into digital form. This is already explained here. The priority encoder, which is generates the binary number based on the highest order to active input, so ignoring all the other active inputs. Highest value of the inputs it receives, and the lowest value of the output it will deactivates or ignores that. Okay, that is the function of the flash type of A to D converter. Next is the disadvantages and advantages of flash type of A to D converter. So it is once again the simplest in terms of the operation theory. The operating principle of flash ADC is simple compared to other type. So, and most efficient in terms of the speed, and very fast. The comparison to other type of the converter, the operation is very much fast in this case. So limited only in terms of the comparator and the gate propagation delays. The number of comparators are increases. So if you are using the multiple number of as it's a 3-bit counter, if you increase the number of bits, the number of comparators used is also more. That's why little bit complications will happens in the circuit. That is one thing. And coming to the disadvantages, low resolutions. So these flash ADC compared to other type of A to D converter, the resolutions is little bit low, and because as we are using a n number of comparators here, so that is something expensive. So for each additional output, so bit, the number of comparators is doubled. So if you are adding one more bit comparator, if it's a 4-bit comparator, then once again double whatever the comparators you are using, so that will be doubled. That is why it is the number of comparators used as more. So that is, for example, 8-bit if you want to have a 8-bit flash ADC, then you have to require 256 comparators are needed. That is why it is not so what we can say simple in its construction. So these are some of the disadvantages of flash ADC. So in addition to this, so the output processing, everything will be very quick in this case. So these two are the different types of A to D converters. Okay, so in the next video we'll start with the 5th module, that is the phase lock loop and 555 timer. So 4th module is as per the syllabus. So you'll be having a to D converter, signal processing circuits, that is single phase, I mean what is that, rectifier circuit, precision rectifiers, half and full. Then you have a different types of the comparator circuits. So it's a some very simplest and easiest module. Don't just skip anything here. So in the second in the next video, the tomorrow's video, we'll discuss about the next module, that is phase locked loop and 555 timer. Okay, thank you.